All right, let's see. Oh, there it is. So did I not bring the book? Oh, wow. Open right up to it. Oh, okay. So, one question that if I don't get it, it sort of worries me. But again, you always have the option to fail. So if you're not doing the homework, you're going to honestly go there. The book likes to ask this kind of question. And then they have like this. So it could be something called a uniform distribution. So we haven't even talked about that. It could be, so in this problem, it's a binomial probability. We're going to review that real quick in a minute. But does anybody remember what's kind of like the most important thing about a binomial to know? Oh shit, it's been a long time, Jeff. Do you remember what binomial reference is? What does that mean? Binomial. Two outcomes. I love it. Bi gives it away. Sweet. So why two outcomes? What's associated with each outcome that's important to us in statistics? There's a something of something, and there's success and failure. Good. So probability of success, probability of failure. What's the letter we use for the probability of success? P. And then there's Q. Kick ass. Right? It's amazing. We're so creative. We're like, what next letter? Let's use that next letter. What else do I need to know to kind of plug? You remember the formula? How's the formula flow? You guys remember that? Oh man. Ooh. I'm easily amused. PX. That's a great start. Yeah. N. So what's N? Yeah. All right. So what are kind of the two most important things about the distribution itself to know? N. And then there's one more thing, because I can calculate the other thing off of this. P. Okay, today we're going to talk about uniform distributions, and there's two important things to know there. If there was a normal distribution, what are the two most important things to know about that? What are kind of like the two things we always calculate when I'm given a list of data or a different way to list the data? What are the two things that we calculate to summarize the data? So if I have a group of data, what do I try to calculate to get a feel for that? If I have a group of grades, the very first thing I want to calculate is the mean. And then I want to know the standard deviation. Where's the middle? How far away from the middle does it get? It gives me a quick visual in my head of what the data kind of looks like. All right. Coolness. So that question is just going to be, you could even just say that's part C is this one. Is that the one you're asking about? Let me see which one. Oh, 84. State the distribution of X. You could just say it's binomial. No? Yeah, well, you asked the question, right? Okay. Right, because that's what it is. It's kind of a giveaway because it's in that section 4.3, which is all about binomial distributions. Okay. Anything else about homework stuff? Yes? Oh, we're going to just go right through this. Let's see. So in this problem, they tell me let's see. Where do you go? Here it is. 4% of the people that call in claiming to have the flu actually have the flu. And then they tell me 25 patients are going to be picked. So right there, what are those two things? 4% actually have the flu, and there's 25 patients they're looking at. What are the variables for those two things? What letter do I use for those two things? Kick ass. P is 0.04.
And then is Q just 25?
Q is going to be what? No. Q's got to be what? Because P and Q are success and failure. Together, they're supposed to make everything. So what's Q got to be? 0.96. So together they make a whole 1. P plus Q is always 1 because they are opposites of each other. Right? If you don't have the flu, you must have the flu. You got to be in one of those two camps.
What number of framework is
This is 85, related to 85, but I'm looking at the setup. And of course, what's 25? And that's the most kick-ass variable. It always means the same damn thing. How many people or things are we looking at? 25 of them. And then 85 says, find the probability that at least 4 of the 25 patients have the flu. How do I write at least in mathish? Yeah, greater than. Oh, shit. All right, come on. Why does that kind of suck in terms of you unfortunately, and actually fortunately, have a teacher that wants you to do this stuff and set it up instead of just push buttons? Why does that sort of suck? How do I answer that question? What's at least 4 mean? It could be 4 or at least 4. At least 4. So it could be 4 or 5. There you go. Or, okay, crazy. Or all the way up to 25, because that's the most it could be. If it's 26 people out of 25, you're going to freak me the shit out. Is this flu mutating and creating new, oh, there's a whole person. Oh. I love you guys. It's too early to talk about mutations of people coming off other people, but it's too bad. I just did. Stay with me now. Come on. That sucks. Do you not agree with that? Why did you assign this problem, Jeff? Because you have a shortcut to this, a little bit of a shortcut. This would mean I'd have to do for 4, or what does or mean? Beautiful, right? Or means that. Or for 5, or for 6, and I'm already going insane, right? Do you want to do the formula that many times? No. So what's the better way to do this? What's the opposite of the question they're asking? True, that's what would I do with it, but what is the opposite of the situation? What's the opposite of at least 4? What's the opposite of at least 4? Less than 4, right? Not an amazing thing. What's the opposite of at least 4? Less than 4. So like you said, okay, I love you guys. Okay, listen up. All right. This is kind of beautiful. Got a problem. It sucks because it's got a lot of shit to do. If it's a probability problem, you think, what is the opposite? Maybe that has less work. But why would I calculate the opposite of what the question wants me to answer, Jeff? I'm going to make the question angry at me, and math is going to get me. Well, no, because what you're going to do is you're going to calculate the opposite probability and do 1 minus that. Then you're going to answer the question. 1 minus something is the opposite situation. If the probability it's going to rain today is 20%, but probably it's not going to rain 80%. I like it. So I can always figure out a probability if I first figure out its opposite. And when am I going to do that? When it involves less work. Makes some sense, doesn't it? I mean, that's just a general life lesson. Okay. So I could do this for this problem. Yeah. What does this entail? What's less than 4 mean? 3, 2, 1, 0. So you have to do the formula 4 times. But I didn't really sign that many problems, so you would do it. So you have to do the formula for 0, the formula for 1, up to 4. So for example, what would it look like for 4? Not 4, Jeff. 3, because I want less than 4, right? What would it look like for 3, the formula for if it was 3 successes? How many total things do I have? 25. So I want to choose how many to be a success. 3. So how many successes do I want? 3. And what's the probability of success? 104. So how many of these do I want? If you got 3 successes, I need 22 failures. So what's the one for 2 going to look like? It's going to have a 2, and a 23. What's the one for 1 going to look like? That's easy as shit. So you just got to do that 4 times. Add them up and then subtract it from 1. 1 minus a probability equals the opposite probability. We know that. You answered that rain question without even thinking about it, but then for some reason you think it's all different when you get into a textbook in a class. No, that's the idea. How could it be different? Okay, maybe. So that was a good question, because otherwise that would take forever to answer their question directly. So we're going to answer it in a smarter way, if you want to. Okay, maybe. Anything else from homework stuff? Or yes? Huh? 92? Oh, good. All right, I love it. So this is the one, I think, I can't remember if it was this one or the other class. Somebody asked, will n always be given? I think it was, will n always be given? Or will x always be given? That's what it was. So 92 says there's a 10-question true-false quiz. So right there, what's n? Oh, I love it, John. What's 10 going to represent? N. This is number 92, by the way. Oh, yeah, dude, you're the one. All right. So there's a 10-question true-false quiz. My favorite thing about true-false questions is the student that gives me this. That's, and I say, what's that? And they're like, what was the right answer? Really? How stupid do you think? All right. So that's not a letter, kids. And I don't like giving true-false anyway. 10 questions, true-false quiz. Blah, blah, blah. And then they randomly guess. They do the Christmas tree. Have you guys ever done that? Multiple choice. You kind of make a design. Sort of like going for the lottery. You're like, I got to get something, right? Anyway, so you are, just by me saying this little bit, you know 3 things. Can anybody tell me one of those things related to the binomial probability I'm going to have to do? You could do it. What's one thing I know for sure? So, n is 10. What else do I know? True, false, right? And they're randomly guessing. So what's the probability of getting a right answer? 50%, 0.5. So of course Q is also going to be 0.5. But this sort of sounds like the thing from probability earlier when I said people gloss over the statement A and B are mutually exclusive. And they try to look for, where's the numbers? Where's the problem? That is the numbers. That's the problem right there. So this little quick statement gave me all this shit. Without this, I can't do anything. So you got to actually read and think. Why did they write this down? Does it have a purpose? Does it tell me something? Now, what are they asking for? They find the probability a student passes with a grade of at least 70%. How do you get at least 70% on a 10-question quiz? What's 70% of 10? 7. So how do I write at least 7 in Mathish? What does that entail then? That entails 7 or 8 or 9 or 10. So again, 4, right? So I don't want to do the opposite. Well, I don't want to do the, what would the opposite be? 6 or 5 or 4 or 3 or 2, that's more work. I'm not going to do the opposite then. I always get students that are like, well, you said to do the, no, only if the opposite has less work. Here, does the opposite have, no, I'm just going to do this directly then. I'm going to figure out what's probably x equals 7 or 8 or 9 or 10. So try to write the formula for what it would look like for 7. And then I'm not going to do any more because you guys could finish it. Finish it.
gonna be greater than or equal to 7? But when are we gonna like? What are we supposed to stop at?
Say it again, sir.
Like because you're doing like the probability of x equals 7 and then so on. So like how long do we do that?
Oh, well, all right. So I got really lazy here because there's only how many more? Well, how many
10.
questions are there? 10.
Oh, okay.
Yeah.
So I found it. Okay, that's nice.
It's up to n, right? So how many answers could the student get right?
10.
At least? How many answers could the student get right, period? He could fail it, pass it, I don't give a shit. How many answers could he get right? Anywhere from what to what?
1 to 10.
You're being very nice. Anywhere from 0 to 10, right? So that's the possible values of x is 0 answers right, 1, 2, 3, all the way up to 10 answers right. So greater than or equal to 7, thank God it stops at 10. It doesn't go forever. Oh, God. Kind of a long quiz. They started that quiz in 1970. All right. So what's it look like, this guy? 10 shoes? 7. 0.5 to the 7. 0.5 to the 3. Some of you guys might realize that every single one of these is going to just have 0.5 to the 10th. Whatever this is, it's going to be 10, isn't it? The one time you can, but I'm not even going to say any more about that because I don't want to freak you out. That is not necessary at all. Set it up like that. Keep going. Set up the rest of them. Or 8. Bam. Or 9. Bam. They're all going to look very similar. And then you just add them all up and you're done. That's the probability you pass a 10-question true-false test quiz if you just guess.
Oh, yeah. So is that a 3 because 7 plus 3 is 10?
Beautiful.
Okay, 8 will be 10.
Yes, if you have 10 total things and 7 of them are this way, how many are the other way? 3. I like it. So this one will be 8 and 2 and so forth. So again, I said that before. A quick check when you set this up is these two have to add up to be this. Because you are breaking them up into you are this and you guys are not this. Nobody can get left out.
So for 10, we put 10, C, 10, and then
Yeah.
0.5 to the 10.
And then 0.5 to the 0. Right? Beautiful. Yes?
For the last 10,
All right.
what do you put, like 0?
Yes, it would be 10. Choose 10, right?
Oh.
0.5 to the 10. 0.5 to the. I want all successes, no failures. The exponents have to add to be 10 in this problem. In general, they have to add to be n. So if you're doing the probability that everybody, that means that one of the exponents is going to be 0 because they're all in one camp. Nobody's in the other. Okay. Hopeful. All right. Anything else from homework? Is that all right? Those are good questions because those are a little bit amorphous. You're like, what do I do with this? But whenever they have a at least or at most or something, you're going to have to do possibly multiple probabilities to get it. Okay. Anything else from homework stuff? All right. All right. So we're going to get back in. We sort of reviewed this a little bit. Let's do a full problem out just to remember how this works. Okay. So let's say that 84% of Americans just want the election to be over. We're already sick of all the shit. We're sick of all the town halls. We're sick of all the debates and shit. Just let it be over. Let giant meteor win. Kill us all. All right. Okay. And then I take, what you got, Jeff? I take 79 Americans. What's the probability that, let's do this, more than 77 want the election to be over? So how do I do that? What does that mean? What's a better way to kind of spell this out? What's greater than 77?
78 and 79.
There you go. Cool, right? So it's probably x greater than 77. In this case, it could be at most 79, right? I can create people, but not that quickly. I want to say 80 people. You gotta wait a while. So 78 or 79. That's why I made a big deal back when we were talking about and or. And is multiply, or is add. If you just remember that, a lot of the stuff we do later is going to be easier. So take a minute and try to set the formula up for both of those. And you can do this for yourself. And you know all these things here. What's this first guy look like? $78, I like it. What goes in here? Yeah, because what's n in this case? 79, p is?
116.
Get really used to immediately changing them into the actual numbers, percentages. And yes, I know that humans created numbers entirely too, but percentages are really, we created them to make numbers easier to look at. So change your percentage into what number it actually is. You try to plug the whole percentage number into an equation, you're going to get some freaky ass answers, as some of you guys saw in that last quiz, right? So immediately make them decimal. So in here, I'm sorry, you said 84, how many of those? 78, so how many of these? One of them, I like it. And what's the other one look like? It's basically the same, yep, 79. Good.
And then times 0.84 to the 79 point, oh wait, yeah, and then times 0.16 to 0.
Yeah, I want none of these. I want them all to succeed and none of them to fail. Okay, how y'all feel about that? I mean, on one level, I'm like, please realize how beautiful that is compared to some other formulas we use. It sort of sets itself up. This many people, I want to choose this many to do this, and the rest do this. Bam, 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 bam. What do I check about these two things? They add up to the total number of people, so I don't leave anybody out. Poor dude out the bill. I'm like, shit, come in here. So let's see. Try to do that in your calculator. Anybody need to borrow? Come on up here. Let's do that now. We're going to need these later.
Can I give you my phone?
Sure.
Because I don't have anything.
Still on eBay real quick.
Thanks.
Oh, it's a little scratched up, but I can still get something.
Oh, she's damaged, yeah.
Oh, what am I doing? That's amazing. All right, so take a minute and try to plug that into your calculator. Oops, the wrong one. There we go. So let's see. All right, here we go. I'm going to catch up to you guys. So 79, math, choose 78. And see how I had to hit over? Now, if you have an old one where it says like NCR in the middle of 79, 78, you don't have to worry about that. Yeah, the older calculator, in some ways it's better. Times 0.84 to the 78. Got to hit over to come back down out of the exponent. I can zoom in a little more. There you go, buddy. God, that really looks horrible. Oh, there you go, man. Look at you remembering shit. All right, times 0.16 to the first power. I'll have to put that. Agree with me? So I get that for this. Look at that grossness. What I could do is just put that in and then put plus and keep going. Let's see what happens if I put this in. 79, choose 79 times 0.84 to the 79 times 0.16 to the 0. And then what's really funny about me plugging all that shit in, it's really hilarious. What is anything to the 0 power? 1. What is, how many ways can I choose 79 from 79 things? You can do it. One way. Take them all. Done. So that's 1, and that's 1. So really, I just had to worry about this piece. But you don't have to know that. You can plug it all in there. You don't have to know that. And let's see what we get. Do we get something decent or just gross still? All right, and how do I interpret that? What does that mean? Oh, you missed all of that. Here, that's what we did. All right. If you're homesick, I hope you feel better. That's gonna be a weird part. Somebody's high is like, he's talking to me. So what does that mean? That means 1.673, let's say, let's approximate it. What's E mean? Don't write this. What's wrong with just writing that? It's bigger than 1. That sucks. So that doesn't make a damn bit of sense. And don't say, well, that's my calculator said. No, it isn't. What's the E mean?
To the negative.
Times 10 to the negative 5th. Oh, shit. Scientific notation. How do I write that as a regular decimal?
1, 0.
I move that decimal place how many times where? 5 times that way. And I'm bad with left and right, so I always remembered negative power means small number. You guys remember, real quick, just deal with me for a year. Like, that's all we do in this class is deal with you, Jack. What's a negative power mean? I love you guys. What's a negative power mean? It's a 4-letter word, starts with F. You can say in mixed company. Negative means flip, right? Flip. You guys remember that? It means reciprocal. It means whatever. So I'm actually not multiplying by 5 tens. I am dividing by 5 tens. That's why it makes sense that this is going to get smaller. It's going to move that way. No? Yes? No? So I'm going to move it once to get around that. And so how many zeros will I have in front? We can do 5 total. So once. And then I'm going to have how many zeros? 4. So to be honest, I don't need all this shit, but still. All right. That's approximately what it is. Why does it make sense that it's such a small probability? Did we do the mean and standard deviation, the little tiny formulas for N, P, and Q problems? Remember that? Does anybody remember what the mean formula was? In fact, if you forget what the formula is, just do what makes sense. How many people would you expect out of 79 to want the election to be over? Well, 84% of everybody wants it to be over, so 84% of 79 is how many I expect. What's another name for expected amount? Mean. So the mean is N times P. So what's the mean here? 84% of 79. Anybody can help me out? So I expect about 66.36 on average. So how likely would it be then that it's more than 77? Pretty small, because I expect it to be close to 66. So that answer makes sense. It's a very small probability. Okay, maybe. Okay. Okay, so let me give you this. As soon as I find it, there it is. This is a little practice problem about binomial stuff.